name is Stephen Gottlieb, and I made up the geometry video. At this point, I would just love for you to sit back and view a sample demonstration. That way you get to see a little bit of my teaching style. How about we get right into it? I'm going to talk about central angles, inscribed angles, and their arcs. If this is the center, if you draw two rays from the center, go from the center to one point of the circle, from the center to another point on the circle. If this angle is x, then it turns out that this angle this arc that was cut off is also x degrees. It's also x degrees. Now, this is not a proof, but why is that? Well, imagine we cut it into a few pieces. Now, this angle plus this angle plus this angle plus that angle adds up to 360 degrees. Goes all the way around. Now, this arc cut off this piece, and this central angle cut off this portion, and this central angle cut off this portion. Notice there's no overlapping. And lastly, this angle cut off this arc. It cut off these four angles, which added up to 360 degrees. This angle plus this angle plus this one is 360. It cut off all of their perimeter, all of the circumference, which is 360 degrees. There's a one-to-oneness. This angle here and this arc here have the same number of degrees. What does this mean? It means that if we consider the following. If this is the center and this angle here is 22 degrees, then this arc here is 22 degrees. Center. If this angle is 110 degrees, then this arc is 110 degrees. They're the same. If this arc here is pi over 4 radians, since it doesn't, we know it's an angle, and it does not have the degree symbol, it must be radians. Then this arc that we cut off is also pi over 4 radians. There's a one-to-oneness between the central angle and the arc that it cuts off. Now, what if you have an inscribed angle? Get rid of this. What if you have an inscribed angle? Okay. An inscribed angle is you have a point and then you draw two chords to the end of the circle. Now, if we were to complete this, that is, we now have a triangle. this angle cut off this portion, this inscribed angle cut off this arc. Now, if we consider this inscribed angle, it cut off this portion of the arc. And now this angle up here, it cut this off. All three angles in that triangle, which add up to 180 degrees, this angle plus this angle plus that angle adds up to 180 degrees. But yet, it cut off 360 degrees of the arc. 180, 360, 2 to 1. If this angle is x, then the arc that it cut off is twice x. And that's how I remember that it's 2 to 1. Or 1 to 2, whatever you prefer. If this is 30 degrees, then this arc, 60 degrees. That is from here to there. All of this. 60 degrees. If this angle is 85 degrees, double it, you get 170 degrees. And now you know the arc. If it's inscribed, you double the angle and you get the arc. 170 degrees of the arc. This angle is pi over 3 radians. You double it, you get 2 pi over 3. That is how long this arc is. When the vertex of their angle is on the circle, find out what it cuts off, and there's a 1 to 2 ratio. If you knew that this arc here is 100 degrees, take half of it, and you know what the angle is inside. You need to understand that it's 1 to 2. When the vertex is on the circle. If the vertex is in the center, even easier. They're equal. If this arc is 2 pi over 3, well then that angle is 2 pi over 3, if that's the center. If that angle is 2 pi over 3, then the arc is 2 pi over 3. You have this 1-to-1 correspondence. If this is the center, and I consider this angle, it's going to be 60 degrees, just like that one is. They're the same. They're the same. You don't want to see this here? Fine. If that's the center, we're okay. Now, if this is not the center, and it's not on the perimeter, then we really can't tell. We really can't tell. I mean, if that is the center and then I put it here, you should realize that this angle got smaller. All I can tell you is, if I come way out here, this is 30. If I go to the center at 60, this angle right here will be between 30 and 60. If you went over here, if Forget about it. It's going to be more than 60. 30, 60, in between 30 and 60. And it's going to be, this angle is going to be between 60 and the largest it can be, which is, I guess, 360. This completes the sample from my geometry video. Hope you learned a little bit about inscribed and central angles and their arcs. I hope that you enjoyed watching the videos. Thank you for watching it to the very end. And most of all, great success in your geometry class. Thank you.